Hello and welcome. In this video, we'll continue our discussion on time series data. In the previous video, we discussed that all time series data contains some noise, and smoothing is the method or a technique that can minimize this noise. It allows us to identify the demand patterns and demand levels better and estimate future demands more efficiently. Let's understand this with the help of an example using the Amtrak ridership data. You can find the Excel file in the course materials. From the last video's visualization, you can clearly see a lot of movement in ridership values each month. In other words, the numbers are jumping around. We need a number that removes all this jumping around or variation from the data, so that comparisons over years become easier. Removing the jumping around of numbers in the dataset is called smoothing. Smoothing methods provide a clearer view of the true underlying behavior of the series. There are two smoothing methods that are very popular across industries. They are the moving average method, and the second one is the exponential smoothing method. Moving average rank among the most popular techniques for filtering noise from the data and make the time series smoother. A moving average is calculated by adding consecutive values of data, or monthly ridership in our case, and then dividing that by the number of time periods in the calculation. Depending upon the way we choose time periods for moving average, the moving average method can be further subcategorized into centered moving average method or the trailing moving average method. In centered moving average, the value of moving average at time t is computed by centering the window around time t and averaging it across the w values within the window. While in the trailing moving average method, the window of width w is set on the most recent available w value of the series. Calculating both centered moving average and trailing moving average in Tableau is an easy task. The idea is to use the table calculation for calculating the moving average. Let's dive into Tableau and load our data to see how this could be achieved. In this demonstration, I have already created the line chart and will now continue to calculate the moving average. For getting centered moving average, under summarizing values using pane, provide previous value as well as the next value. Let's say we want to calculate a 13-month centered moving average. We'll put 6 in previous values and 6 in next value. And we'll also choose the checkbox for current value. We'll tidy the visualization a bit by overlapping the two graphs and synchronizing their axes. We'll notice the orange line is much smoother when compared to the original blue data. Similarly, for getting the 13-month trailing moving average, we'll duplicate the centered moving Tableau sheet. We'll edit the table calculation, put 12 in previous values, 0 in next value, and choose current value checkbox. That's it. Again, the moving average line is much smoother than the original data. Although theoretically we could use trailing moving average method to calculate the forecast, but Tableau prefers to use exponential smoothing method for forecasting time series data. So let's spend some time understanding what exponential smoothing method is. In moving averages, the past observations are weighted equally, while exponential smoothing assigns exponentially decreasing weights as the observation gets older. In other words, recent observations are given relatively more weight in forecasting than the older observations. The formula for calculating the forecast using smoothing method is given by equation f t plus 1 is equal to alpha times dt plus 1 minus alpha times ft, where dt is the actual value of the demand at time t, ft is the forecasted value, alpha is the weighting factor which ranges from 0 to 1, and t is the current time period. As managers, you will be more interested in the forecast numbers. So let's look at how you can achieve that using Tableau. In the Amtrak Tableau file, add another sheet. Create a time plot for ridership by putting numbers of passengers on rows and time in months on columns. Then, from the Analytics pane, put forecast on the chart by double-clicking it or dragging it. You'll notice that Tableau has generated a forecast for you. The estimated values are shown by default in the lighter shade of the color. The shaded area in the visualization shows 95% prediction interval for the forecast. This means that the model has determined that there is 95% likelihood that the value of the number of riders will be within the shaded area for the forecast period. You can configure the confidence level percentile for the prediction bands and whether the prediction bands are included in the forecast or not by using the Show Prediction Interval settings in the Forecast option dialog box. To do that, right-click on the visualization and mouse over Forecast and choose Forecast options. The bottom sections of the options contain choices for prediction interval. We'll leave it as it is at 95%. There are multiple ways in which we can see the forecast results in Tableau. For that, you'll need to click on the number of passengers field to open its menu and mouse over on the forecast result to see all the options available to us. More information on these options is available on Tableau's official website, and I would encourage you to read from it. Let's now move on to the last section of today's video and see how you can configure the forecast model itself. Again, right-click on the visualization and mouse over the forecast to choose forecast options. From the forecast model section, select forecast model as custom. This will make the trend and season field visible. Try and recall the concepts of additive and multiplicative series from the last video. These options reflect those concepts. So go ahead and choose these values as additive and additive, or additive and multiplicative, and see which forecast works for you. You can find more details on the Tableau's official website, and again, I would encourage you to read from it. Before we finish, there are two important things to remember with these options. First is, you cannot use a multiplicative model when the measure to be forecasted has one or more values that are less than or equal to 0, or even when some of the data points are too close to 0. The second one is, you cannot specify a model with multiplicative trend and additive seasons because the result may be numerically unstable. There you go. We've got our time series forecast in front of us, and it's time for you all to go ahead and analyze it and generate insights from it. This brings us to the end of this video. I'll recommend you to have a look at a lot of time plots on the internet and see if you can identify if a time series in them is an additive one or a multiplicative one. Usually, traffic on websites follow multiplicative series. Good luck.